My name is Brook Tate. It's all happened kind of within a month's time. I came to India and I stood on this wall. I jumped in this lake, jumped straight on a seashell. A shell went in my foot and cut my foot open. And then I couldn't walk properly for about two weeks. And I had a very strange feeling that I needed to do maths. But maths is not something I find very easy at all. And resulted in this. And now I can't quite believe that I've written my own maths book.
Munroe Island is located in the southern state of Kerala, just below Alapi, and is reputation as one of India's most peaceful scenic spots. Many travelers find themselves attracted to its backwaters, and in December 2023, a bald Englishman arrived with the intention to switch off for a few days and take a break. Little did he know, he would stumble, quite literally, upon a whole new world of maths. I met Brook while volunteering at Santa Maria Hostel, and I was intrigued to find out more about what he was creating. So Brook, where did it all begin?
I guess it started a few months ago when I was in England. I had this random thing that I still couldn't do maths very well. As in, not just couldn't do maths, but I was completely just afraid of it. I was just stressed whenever I did it. And then it meant that I just didn't look at change in my hand. I was rubbish at times and dates. So I bought myself a maths textbook, which was made for middle grade 8-year-olds to 13-year-olds, and I was like, well, okay, this is where I can start. And then I had this thing of I need to go away. I just wanted to have a bit of a break from doing art so much and performing. And I thought, well, while I'm on this break stuff, I'll look at maths again, because I thought it would be one chance to do it. So I was like, no, I need to go to India. And I found on Google, on this blog, a place called Munroe Island. And everyone I was telling, I was like, I'm going to go to India and I'm going to learn maths. And my friends were like, that's ridiculous. And anyone I was telling when I was in India, they were like, what the heck, why? And it was a bit random, and I do realise it was random. But something in me was like, I just need to do it. And I found this place called Santa Maria. I was just about to go and explore the island, and this guy said, oh, do you want to go swimming in the lake next to the island, next to the hostel? And I was like, yeah, sure, okay. So I put on my swimming shorts, I climbed onto the wall and jumped in, and a seashell, cut right into my foot and literally went a centimetre deep, and it was quite wide, and I pulled it out of my foot, and then just blood started gushing out of my foot, and everyone was like, oh my God. So I sat on a chair, had blood down my hand, and then they were pulling it open, pouring turmeric into it. Is that normal?
Yeah, kind of.
Yeah, but it worked. And as soon as it happened, I started laughing, and I felt so relieved, because I think part of me knew that I finally had no choice but to stay still. So I sat under this tree, this beautiful tree, every day for about a week. I had my notebook, and I was trying to work out ways of just understanding numbers, just basic numbers of how they related. But I was trying many different techniques, but I just couldn't get it in my brain. I just couldn't see it properly. And then on the 31st of December last year, 2023, by being so inspired by the colours of India and this town, this village, I realised that there were kind of 9 main colours, plus white is 10. And I wrote it down here on the top of this page, and I just painted the numbers according 0 to 9, with black as 1, 2 brown, 3 pink, 4 red, 5 orange, 6 yellow, 7 green, 8 blue, 9 purple. And I just thought, well, in that way, there's a code there. There's some kind of code that I can stick to. I tried different ways of adding and calculating, but it just didn't work, and I couldn't work out how to do it. But the idea stuck in my head. And then a girl who came to stay at this hostel said, oh, have I heard of Vedic maths? And I hadn't. A method of maths that's from the Vedas, and ancient Indian books. And I hadn't, and I researched it, and something about that one of the earliest stages, the first stage, is mastering the calculations of 0 plus 1 to 9 plus 9. And I'd already started writing this out on an earlier page, but thought it was too simple. Why was I focusing on something so basic? But actually, that was the very beginning of this whole process. So I wrote down all of these calculations, very basic calculations, and I painted them. And when I painted them, I could see finally the numbers moving in a pattern where the answers were moving, as well as the calculations. And I thought, okay, there's something there. So I tried writing out different ways and different representations of how the numbers could be presented next to each other. And then I thought, I need to step up. I need to paint the times tables, the multiplication table. So I did all the way through to 20 times 20. And then I started doing it on my iPad, and I realized I could shift the patterns around. But the numbers that we have in just normal numbers, where we have the like a 4 and a 5, 45, they can't be reflected. But this whole table can be reflected like a mirror. So I thought I had to find another way to represent the numbers. And that's when the idea of circles started coming into my head. Because a circle, if you split it down the middle or either way, will always look like a circle. And then this whole journey started of finding a language and a code and a system to represent this way of doing maths. What is blue plus black? Purple, yes.
How does this fit into the story?
Because I had cut my foot, I hadn't been out walking or exploring over the island at all, really. But I started doubting whether the circle part of my idea, so like using the outside ring representing the tens and the inside ring representing the small digit, the unit, and I'd just gone ahead with it and started drawing, but I started doubting myself whether it was right. And then I was crossing back over the railway track from the corner shop back to the hostel, and it was so hot, I was like, I'm just going to go back to the bridge. And then I stopped and I was like, you should cross over the bridge because maybe there's an answer across the bridge. And then I was like, and I thought, no, come on, Brooke, cross the bridge. So then that's when I crossed the bridge, and what was over the bridge blew my mind. So how exciting!
Let's go see what was over the bridge. At what point did you realize that you were onto something?
I don't really know. Once I'd realised that there were 9 main colours, I was like, okay, so there is this already. There's a code of 9 things, and then plus 0 is 10. And I was like, maths is presented in schools, or at least when I was a kid, it was presented as like always a challenge. But if there is a way to present maths really beautifully, introducing the world of maths and the relationships of numbers in a really beautiful visual way, and my friends who are like good at maths and they're like engineers or people that just use maths in their jobs, they're always like, the patterns in maths are so great and beautiful, and like once you can see them. And I was like, well, I really want to see the patterns in maths. So I was like, how can I find a way of opening the world and presenting the world of numbers in a completely different way? So now we've crossed the bridge.
Ooh.
And now we're getting closer to the sign.
Do you think the universe gives you that sign on purpose, and it has helped you throughout the maths thing?
Because I grew up quite religious and then left that mindset, for quite a few years I've been very averse to being no, the universe doesn't work like that. And I still don't know, but it's been so funny and interesting and amazing and exciting seeing how many things have led me to make this thing, which I would never have thought of and created had it not been for these
indications.
Yeah, indications, and genuinely, this thing was such an encouragement. It was like you're on the right track. Just keep going. Yeah. So that's how I took it.
Because throughout your story, there has been so many indications of you stumbling upon it that has helped you in creating more maths, creating more things, the patterns you see, the patterns you notice in this Munroe Island as well. So that has helped you, I think.
Yeah, oh, definitely. The word inspire, the word inspiration is such a beautiful word because it's in spirit. It's like injecting spirit into you. It's like so inspiring.
Nice.
Yeah!
Oh my God.
What is red times 2?
Blue.
Is it blue? 8. Yeah. So yeah, the system was pretty simple once you get the hang of it, and you were like one of the first people I showed it to, and you seemed to get it pretty easily.
Yeah, but I think once you get the hold of the numbers and coordinate it with the colors, it's pretty simple to get.
Yeah.
Like, fits into your brain.
Yeah.
It's pretty. It's very pretty, actually. Beautiful.
And which is just the words which I would use to describe this temple, which is the thing that we came over the bridge for.
Oh,
because
my
I
God.
came and walked up to this temple and was like, oh my goodness, if there's ever a sign, this is it. Because I've been to India a few times and I've never seen a temple like this one.
I have lived in India and I have never seen this temple.
With
This
the
designs with the circles. And
Yeah.
it matches exactly with your
I
theory.
know. So like I was like, I came to it and I was like, no way, this is
No.
absolutely bonkers. This was my notebook already, and I'd drawn all these circles and circles within circles, and this was exactly the section that I was questioning. So then to come here and see this was very much a sign to be like, okay, it works, keep going.
We were
Bonkers.
talking about universe giving signs. I don't think there has been much bigger sign than this.
Yeah, I know. So at
Look.
that point, I know.
It just matches exactly.
I came through this little path and then I looked over here and there was this absolutely beautiful tree, just this one here with the light falling on it. So I got out my sketchbook and I just tried to draw it, and at this time it was starting to get dark, so I was getting bitten by mosquitoes, and as I was drawing I was like, oh, it's surrounded by green. I was like, instead of drawing leaves, I could draw circles of green. At that point I was like, okay, so certain parts of nature can become like mathematical calculations. Once I'd got encouraged by the temple, I was like, keep going.
Why did you choose the shape circle?
Well, way back in like 2017, I did a painting of a girl called Hannah and of my best friend Attain. And it was the first time I had used my own design. Someone had a few weeks before said how powerful circles are, and how when you sit in a circle you can see everyone, and like discussions are more effective in circles and things like this. And that was way back in 2016, and it inspired me to start painting circles behind people's heads. And I had a little blue bead on my earring from a bracelet of my niece's. So that was, and those like ingredients created a painting style and a portrait style that I fell in love with, and I felt like it was something unique and identified my style of art. I think that was the beginning of me being like, oh, I really like using circles. They're just such like a nice shape to look at. And yeah, circles are just like a very like beautiful shape. They're very natural. Like, are they quite natural? Well, I think they're interesting because you think they're very natural, but you don't see many perfect circles around. I don't think so. I don't know. I mean, the eyeball.
oval.
There's the eye. Yeah, there's the eyeball and like droplets of water. Anyway, circles are great shapes. I just really like circles. So it just seemed like the most obvious place to start. The circle image is saying that the number is just saying, this is what I am. I'm not doing anything. I'm not a calculation. This is what I am.
Do you use any more shapes in your theory?
Yes. Triangles represent, an upward pointing triangle, like a pyramid, represents multiplication. So it takes a number below it and it multiplies it by the colour that it is. And then I realised that the flip of multiplication is just division, and that's represented by an upside down triangle. And also that was a thing for maths for me. I was like, I didn't realise that, as in like you can multiply a number by something, get the answer, then you divide that answer by the multiplication and you get that, which is probably really simple, but I just didn't get that. So that was really exciting for me, recognising and realising the symmetry in maths. And then with the addition addition. Before, I just put two circles on top of each other. And then I thought, oh no, it's maybe not clear enough because it's not telling you what the shape is doing, or what numbers what doing what. That was a complicated sentence. Mumbled. And then I was talking to people and I was seeing the pointed
bindi.
Bindi, but there's circle ones and then there's pointed ones, aren't there?
Like a droplet.
A droplet. And then that's when I was thought, an upwards one can be like a balloon expanding for addition, and then a downward point, like the flip of that, like a teardrop, I was thinking could be dropping, so we're dropping the amount. So that just became, those two things became symmetry as well. What is yellow plus 1? Green. I do also have squares for square numbers because I just thought that was obvious and a clear way to visually remember square numbers, because every time you see a 9 you can remember that a 9 is a purple square. And through teaching this guy called Louis, he was like, oh, isn't 64 a square number? I was like, I don't know. And then he drew a yellow square with a red square inside of it, and then afterwards he was like, okay, I think that's 8 by 8. And now I know that because I can remember the image. Mm-hmm. I knew that there was a yellow square with a red square inside it. And I thought, 64 is a square number. And then teaching someone else, we put a blue diamond because it's doing something, it's pointing up. Yeah. And above that is a yellow square with a red square in the middle. So all these shapes are helping me, at least, remember mathematical facts and properties. So yeah, shapes are fundamental to the whole system.
Wow, so the temple answers the questions, but what next?
So the next thing that happened, I was like, but maybe I've chosen the wrong colours to represent the numbers, because I was thinking maybe it shouldn't be brown, maybe it should be like dark blue and blue, like indigo, like the colours of the rainbow, and maybe to make it more colourful. And I had this for the next day as a question in my head, and then the mathematician Alan Turing, have you heard of Alan Turing?
Yeah.
So in World War II, he was a gay mathematician and a genius, and he was just like, he stopped World War II 2 years earlier and saved millions of lives with his code-breaking skills. And I'd only just found out about his story properly before I came to India, and then I started writing him little letters, just as a little way of keeping note of what has happened.
Yes, exactly.
And I was like, this thing has happened. Hi Alan, I've made this code and it's really cool and exciting and I'm excited about it. And then I was like, but I've got this dilemma. I don't know whether to change the colours. And I wrote his birthday out 3 times. One with the original way, with brown. One with another one with a different place of green. And one with indigo instead. And I wrote out his birthday and I was like, let me know what you think. Any thoughts? And then the next day I was sat and I was on the phone to my mum and dad, and these little things were floating in the water. And they had little buds of the flowers from the tree I was sat under, and they had a yellow outside and a brown middle, and it looked really beautiful. And I was like, okay, there's brown there and it's in a circle like the rings. And then I was like, okay. And then there was this guy called Pramod, who I had been speaking to, and I wanted to talk to him about this festival that's been going on for 10 days, because this island is actually usually very, very quiet. The whole year, apparently, apart from these 10 days. All the music, and I was trying to find him, and I got on the bike, and I was thinking I need to try and find where he lives, or just when I see him I need to talk to him. And I came out and I was driving, but I didn't know where he lived, didn't have his number, and I came down and he literally stepped out onto the road as I was out of the forest, the trees, and I stopped my bike. It's like, oh hey, and he shook my hand, and he had this ring on that was so blatantly just so colourful. Shook his hand and I was like, oh my gosh. And I looked at it closely and I was like, oh, can I just look at your ring again? And it was nine gems, and in it there was 1 blue and 1 brown, and immediately I was like, there we go.
There's the sign for you.
There's the sign. There we go. There's the colours. I'll just stick to the original colour code. And yeah, from then I was like, right, okay, now just go for it. Now just make this thing a thing. So yeah, now I'm in the middle of making the book. I've made my first document PDF to explain it all, and yeah, it was very exciting.
Nice.
Yeah. Yeah.
Have you experimented on children in the Munroe Island about this?
Yes, so I did actually so in the corner shop when I went in to buy some colours, I explained to them, or tried to explain to them as best I could. I explained to them, and there's the son, Shreyas, he immediately got it, he understood, and he could understand the times table system and everything, and that was when I was like really excited by it. And then the next day I taught him and his friend, like sat on the steps. And they got it, and they started making their own images and patterns. And then the next day, like another bunch of kids came up and were like, "Can you teach us the colour math, or like the colours?" Off to teach my first class of colour maths, multicolour math to some kids. So we went and sat in the clubhouse and did this whole class, and that's when Marco arrived, and it was so nice, and two guys, Alex and Marcel, and we just ended up like with this little school, and we were doing the colours and pictures and drawing like coloured halos above their head, and it was so engaging and so interactive and so fun, and they all were like really enjoying it.
2 plus 10, 12.
Yeah.
12 plus 12, 24.
Right. And I was really enjoying it. I was like, how am I sat here I wasn't really teaching maths, I was just like showing a system.
A plus 10, 18.
So,
The thing is that you don't speak their language and they don't speak your language, so it's really breaking the language barrier between people to understand maths visually and mathematically.
Yeah, that's what I was thinking. I was like, wow, I never thought, I suppose numbers are an international language, so this can also be an international system. So it was really very, very exciting. The whole thing is just so exciting.
What do you think is the future of this method?
I have no clue, I don't really know, but what I do know is that it's helping me enjoy maths, because now I'm like doing it in my mind, just making a mandala so beautiful, or like the images, the calculations, so it's like encouraging me to want to do maths, and like mental arithmetic, and this guy at the hostel said, "Brook, don't worry too much about how easily you can communicate it to other people at this point. If it's helping you, that's the main thing." So I keep having to remember that, and whether me as a 7-year-old at school, when I started really finding maths difficult, I would have loved this. So hopefully, I'm hoping that in the future, or at some point, other 7-year-olds and other people that struggle with maths can benefit from it. So we'll see, fingers crossed, who knows. And what's exciting is just today I had a phone call with the director of the international school, which is a few kilometres away, and I'm going to meet him tomorrow to talk to him about the method, because one of their students had heard about what I was doing, and I spoke to them yesterday and they gave me their email, the school's email, and so I'm meeting them to potentially go and teach a test class in the school. And what's hilarious is the school is called Brook International School, so there's another little like nod from the universe, I feel, or I'm taking it as a nod from the universe, to go and try it out. Red is, pink is, brown is, black is, white is, 0. What is purple plus 1? 10. Yeah, is what is pink times 2? Yellow. Okay, blue divided by brown. Red. Yeah, perfect. And that's when I decided that the method could be teachable. And so, through doing all of these drawings, many pictures, many paintings, I thought, oh, this is a picture book. It's not just a maths book, it's a picture book, and it's an adventure around an island to try and inspire the reader. And then it just became this beautiful visual adventure for me, realizing that animals could become calculations, plants and trees, patterns, the elephants. I love elephants. So that's all the sketches, Then a filmmaker from Bristol came to the island with the idea of making a short film on real film, and Monty led the way and directed this film in a young boy called Abby, who was from the village, and it created a whole hero kind of character for him, who saved this very challenged scientist man. Not that I'm a scientist, but someone that was struggling to understand and keep faith and hope in just life. So Abby became this character, and then as Abby was there, I was like, this is the last ingredient missing for this book, a character to guide people and introduce people to this system of maths. So then, through all of these page designs and ideas and sketches and many random, very abstract ideas and thought processes, eventually it has come to a press house to bind books, because I'm hopefully today going to print my first copy of Multicolour Maths on Munroe Island. We're going to print it in full colour and bind it nicely. So that's the goal today.
But what's that haze upon the river? Or what's that mist above the sea? What's that hum in the morning when it's just there in me? I cannot name that color. But what's that haze upon the river? What's that mist above the sea? What's that hum in the morning when it's just there in me? I cannot name that color. I cannot name.
Anita has hand-bound the first copy of Multicolour Maths, the first version of the world. Eventually, it has resulted in this. And I can't quite believe that it is existing, because less than 2 months ago, I was terrified of maths. This is the book. It's for Alan Turing, 8-year-old me, and anyone who cannot answer 8 times 3. And Alan Turing is very much an inspiration for me in this. This is Niram, which means colour, the character that shows you the art of calculating in colour and colour calculation. Little phrases like, take your time and find your pace. Remember, math is not a race. The magic of mistakes, how everything can remain beautiful even with mistakes that we make. I hope that multicolour math can be something that opens doors for children and for adults that might have otherwise been closed and remain closed, because one of the reasons that I think maths is so beautiful now is because so much symmetry is everywhere, and symmetry is maths, and realizing that you can paint it and it can be in this color coding way, because it relates to like a leaf. 1 minute, I didn't want to pick it from a tree, so it's an old one, but like I was just looking at these leaves, and when I was sat under this tree, like, leaves are symmetrical, and they're so beautiful, and there's so much maths just in their vein system, and just these lines, these veins, actually repeat in the branches of the tree, which is so exciting. For me, that's so exciting. It's like the tree has its own version of maths, and it's all visible in the leaf, and if you look under the tree, you can see it. So I kind of feel like at the very beginning of seeing the world in a different way, and it's all through taking the fear out of maths for me. And I just had a moment where I was thinking, wow, there are so many creative minds. Well, everyone's creative, but like, if you can't grasp maths, you end up shying away, or I ended up shying away from science and from all the like technical stuff. But really, if you love painting, and if you love colours, if you love dancing, if you love singing, if you love music, your mind is so brilliantly working creatively, and it's doing its own version of maths, its own magical creative maths. And it's the creative brains that are needed in the world to think of different ways of doing things, because as we go into the future and like as the years go on, the people that need to be really confident at working out how to do those things will be the ones that love painting, that love dancing, that love like making music. So what I'm saying is, I'm hoping that this system can encourage people, maybe you, if you're struggling with maths,
to think, no, I can do it. I just need to find a different way, and I just need a different way, and then you can start like I don't know, accessing things that maybe you don't think you're able to do. But we can all do things. We can all do much more than we ever thought. I never thought that I would write a maths book, but here I am holding one. Who would have guessed? So in the words of Niram, slowly, boldly, brightly paint one sum and then another, and soon you'll see that just like me, you'll calculate in colour. Keep looking, painting, playing with this magic you now know. This art of multicolour math on the island of Munroe.
Hey, Brook.
Hey, Hadassah.
You really inspired me because you made me really properly think about the importance of education, basically. Then you kind of exploded it into how considering this could help other people.
I know that everything I feel now and think and wish is out of structures that were built inside of me during all the years of my life. And you know, it's when we are already adults, we rethink about the things and try to check if we have too much solid structures that prevent us from seeing the things as they are and not as we want them to be or as we think they are. And I think education, you know, like children, they will be one day old, and some of them will take a big decisions for a lot of people. Some will affect their surroundings, their small surroundings, which is not, you know, it's not a competition. Each person have their own role in life. But if from a young age you let people be who they are and you allow them to embrace their beautiful powers they have inside, and that they always come from, in my eyes, with good intention. So you open this world, you give them the tools to understand these ideas. Like now, when I see like all the big problems, you know, and all the children that doesn't have what they need in order to be safe and peaceful and happy, it's like, I think what I really connected with your method is just this very precious tools. It brings such a precious tools because you were learning yourself and putting it into your work as well. It's hard for me to put it into words now. I have like feeling of it in my heart.
Thank you.
Thank you.
I cannot name that color. I cannot name that color. I cannot name that color. But I can see.
Hello, my name is Brooke.
I'm a painter, musician, and sometimes I paint my own face and turn into a zebra. And most recently, I've completely and utterly fallen in love with maths. I've discovered somehow a way to paint it without having to look at numbers. And I've released this book, Multicolour Maths, Calculate in Colour, which takes you through, step by step, all you need to learn to be able to paint maths too. Along with the book, I've put together an online course which will teach you everything you need to know to calculate in colour. All you need is some paper, some colours, and an open mind that's ready to learn how to paint maths, the language of the universe. Just visit multicolourmaths.com and get ready for a maths lesson like no other. Crayons out, colours bright, let's calculate in colour.